This is a quick run through of the Gateway 3 exam, and this is the code number. Half of the students in class had this one, half had the other. If you didn't have this code, you do have one that's similar to this. You just have to look for similar problems on your exam. One of the first issues that students have been having is when do you have to factor and when do you have to solve, and knowing the difference between those two things. Well, first it's going to tell you factor, and if that's the case, you're going to have some set of parentheses. There may or not be a number in front as a coefficient for something that was a GCF pulled out of all the terms. For solving, you're going to have a list of solutions. This can also be written in set notation such as this. Either one is correct, but you do not want to write it as something in parentheses, say -4, 3. That means something totally different. And so let's start with the first problem. We've got x squared minus 4. 4 can be written as 2 squared. There's two terms. There is no common factor, and they are both squares, so that means we're looking at the difference of two squares. So you keep the bases for each of the factors, and then you have one sign positive and one negative. For the next problem, number 2, they're asking you to solve the equation. It's already equal to 0. It's a quadratic, so you have two choices. You can use the quadratic formula, or you can factor it. To factor it, you list the factor pairs. This sign is telling us that the factors have different signs, and this one is telling us that the difference in the products of the OI terms of FOIL is going to be a +1. So we look for a factor pair with a difference of 1, and it's 3 and 4, so we're going to use that pair. And what times itself gives you t squared, and then you put a 4 and a 3 in, and again, right here, the bigger number is going to be positive because 4t minus 3t is +1t. Set each of those equal to 0 because you've got a product. And so when you do that, you can solve each of those individual equations to get -4 and 3. For the next problem, you'll notice it's not equal to 0. So what you're going to need to do, distribute on the left, and then the next step from here to here is to subtract 20 from both sides. And when you do that, you now have a quadratic here. We're going to factor it. You look at the factors of 20, 1 and 20, 2 and 10, 4 and 5. The factors have different signs. That's this negative sign. We need the larger product to be negative. We have a -1 here, so the pair that has a difference of 1 is 4 and 5. And so we throw those into place. The larger number is the negative because -5x plus 4x give you -x. Set each of these factors equal to 0. That's the 0 property. And when you do that, you solve each one. For the next problem, for the function f of x, determine f of 5. That is saying here x equals 5, what is y? And you just find the point. And so here's 5, go up, what's that point? The y value is 1, so 1 here is the answer. For number 9, find the x and y intercepts. We know that when we're looking for x-intercepts, we let y equal 0, and when we find y-intercepts, we let x equal 0. And then you just substitute that in. So you set it equal to 0. This thing can be factored. Because there is a constant that is common to all of the terms, you can divide by that number. You cannot divide by x, but you can divide by a number. And then the subsequent equation is factorable. Yes, this is factorable. You could factor a 4 out front as well. Either one will work. 0 property, solve them both for x. So you get 2 x-intercepts here. For the y-intercept, you're going to let x equal 0, so you're finding f of 0, and that's just -20. For number 10, find the vertex of the parabola. Remember, the vertex is given by negative b over 2a, comma, f of negative b over 2a. In other words, substitute the number in that you find. Find negative b over 2a, where a is negative 1, b is negative 2, c is 1. We're not using c, we're just using b and a. Those are really the coefficients and then the constant. Once you get that negative 1, you have to substitute it back in and get the y value. Remember, a vertex is an ordered pair, so you have to have this y. When you do that, you get negative 1 comma 2. Okay, number 11, you have to factor completely. You want to pull out a GCF first. GCF are common to all terms. So for this one, you have a 6 common to everyone, and you also have a t. If you have your scientific calculator, which you're allowed to use on these exams, just take this value here and divide it by the leading coefficient. More likely than not, that is going to divide that last coefficient. If not, some factor of that will, so that you can simplify. Once you pull that 6t out, now you have to factor this. Go ahead and find factors of 88. They're factor pairs over here. This negative sign says you're going to have a positive and negative sign for the factors. That means you're looking for a difference for the OI term, the outside and inside terms. The difference of those two need to be negative 3 for negative 3t. So you're looking for two factors of 88 that have a difference of 3. That's 8 and 11. And the larger of the two products for the OI terms of FOIL need to be negative, so that's the negative 11. For the next problem, solve this equation. It's already factored. We went over this in class today to say you don't have to expand it, you don't have to do anything else. It's already factored for you. Set every factor equal to 0. Well, negative 3 equal to 0, you can cross that out because that is not true. In other words, you could have divided both sides by negative 3. Set the x minus 9 squared equal to 0. Take the square root of both sides. Plus or minus the root of 0 is still 0. Then add 9 to both sides. For the other one, x plus 7, set that equal to 0, get the other answer. I know there was no line on this one. If that really bothers you, you can put a line out here, and then you can just write your answer on that. Next problem, number 13, you need to decide whether the function is going to cross or touch the graph at each of the x-intercepts. Please note, these are factors, not intercepts. To find the intercepts, you need to have, for this guy, x minus 6 equals to 0, so x equals 6, that gives you 6, 0. Next one, negative 7, for negative 7, 0, x plus 2, so negative 2. So you need to really use the 0 property to find each of those. You may write them as ordered pairs in class. I also said you could just list them. For this one, since every factor has an odd power, they're all 1, then all of those intercepts have the curve crossing through or passing through that point. For number 14, you have to determine the y-intercept. You just be paying attention, right? We've done this before. You know the y-intercept is letting x equal to 0. Because it was buried with all of this quadratic and equation solving, you seem to have lost that point. So take a highlighter to the exams with you. Highlight, circle, box, what it is you're looking for. To find the y-intercept, you let x equal 0, so we're looking for f of 0, so you substitute 0 into every factor. Negative 4, this factor, 0 minus 1 is negative 1. 0 plus 1 is 1. 0 minus 2 is negative 2. Don't forget that exponent. 0 plus 3 is just 3. And then multiply them together to get 48. For this page, what you're doing, you're looking for we have this curve here, function, and we've got to decide which of one of these it belongs to. See, I can't shrink this in, I don't think. Oh, that's hold on. Okay, there you go. And so when we look at this function, x minus 5 is telling us that one of the intercepts is 5, 0, the x-intercepts, And x minus 1 is telling us that when x is 1, you get 1, 0, the other x-intercept. So you look at each of these curves that they give you for choices, and right away you can get rid of C because we do not have the correct x-intercepts here, so we cross that y out. And next, we could try f of 0 for the y-intercept. And when you do that and you substitute that in, you get 0.2, negative 5 cubed. This is a positive number, so the y-intercept is going to occur above the axis, and so you can then eliminate choice A. And now what you have to decide is whether you're going to use B or C. For this one, what I recommend you do is to go back to the idea of whether they cross or intersect the axis at each of these x-intercepts here. Since each of these factors have an odd power, x minus 1 is really a power of 1, and because of that, they both cross at those x-intercepts. For this one here, it comes down touches, touches. It's not crossing, so you can eliminate this guy, and that gives you an answer of B. So that's it. If you have more questions, you should take your test to the Math Tutoring Center, to your tutor down at the Learning Center, or come and see me during office hours on Thursday or on Monday. Hope you have a great evening.